So the first person I'm going to introduce is Tyler McFayden. So Tyler is, we think her career is ready to launch in the area of autism. And so Tyler's going to do some, talk about some really innovative work where she looks at the intersection of clinical science in relation to neurodevelopmental disorders and particular domains of developmental functioning, namely language functioning. So without further ado, Tyler, please tell us what you're about.
Right. Hi, everyone. Thank you so much, Andy. I'm going to attempt to do this screen share here. All right. How's that looking? Good. All right. Well, thank you again. I'm very excited to be up here to talk to you all today about my research interests, in particular, what I've been doing and also where I'm going in the future. So again, my name is Tyler McFayden, and right now I'm a rising fifth-year graduate student at Virginia Tech under the mentorship of Dr. Thomas Ollendick. And I'll be talking to you all today about atypical language learning, which is kind of my focus and my passion in research. If I can get it working. All right. So to understand how I got to where I am now, let's take a quick journey back to my previous self, about me at 4 years of age, and clearly apart from being incredibly stylish, I also hadn't developed any expressive language. Could gesture, could use eye contact, but really had pretty much 0 words. And I like to consider the younger me kind of my first experience in what I now know to be called multiphonality, that although I was markedly delayed in language, I stand before you mostly developmentally typical, at least in the linguistic domain. Compare my journey to that of many other kids who start the same way, quite delayed verbally, but remain delayed verbally throughout their life, never really acquire meaningful speech. My questions from that are, what are the underlying mechanisms that drive these quite disparate outcomes? And how early can we actually tell if you're not going to develop language appropriately? As we all know, language is hugely important. It's an adaptive skill that's required for success in this world. But for about 1/3 of children with autism spectrum disorders, or hereafter referred to as ASD, expressive language doesn't really develop that typically. However, remember tiny Tyler, we can't exactly tell who is and isn't going to develop language typically. Only after they fail to develop expressive language do we intervene, and usually that has limited success. But the level of success is dictated in part by how early interventions are able to step in, meaning the earlier the better. So for most kids, we just end up waiting and seeing until language has clearly landed outside of typical development, and only then do we intervene. But my question is, do we have to accept those current success rates? What if we can improve what success looks like in terms of language intervention by modifying the wait and see process? Can we start earlier, before the typical periods of language development even begin? And if we were to start earlier, what signs would we look for? What indicators would we use to track language readiness or language development? My career goal is to be able to use neurophysiological and behavioral methods to predict language levels in infancy as a way to target subsequent language interventions, in particular for those with ASD. So in other words, when considering our wait and see process, my career goal is to be able to shorten the wait time frame to infancy and to be able to change the see window to indicators other than spoken language, to include a host of signs like neurophysiological indicators, and also other populations, such as those with hearing issues, that will allow us to develop modalities optimized to predict atypical language development. So to get to this career aim, I've turned my program of research to 3 fairly distinct groups, typically developing infants, children with ASD, and children with hearing loss. Individuals with autism kind of provide us the signs that help see what atypical social communication looks like. Infants provide us the answer of how long we really have to wait to see when language develops typically. And individuals with hearing loss provide us with clear brain behavior linguistic relationships that can be used to find other signs that we can look for. I strongly believe it's through the integration of all these interdisciplinary studies that including these 3 groups, that will come closer to our language early intervention goals. So I wanted to start off talking about autism. What are some of the behaviors we can use as indicators of speech and language outcomes apart from atypical speech and social emotional reciprocity? Of course, we can kind of use that domain to look at it. But what about the other kind of half, the other repetitive or behaviors and restricted interests, or RRBs. RRBs are behaviors that include, of course, restricted interests, repetitive motor movements, but also atypical sensory interests, stereotype behaviors, and also self-injurious behaviors. RRBs are widely seen in autism and often a clear focus of intervention, but to what degree do they have links to language? My latest work challenges the prevailing assumption that RRBs represent distinct signs from that of social communication and language. Could RRBs in fact represent a type of social camouflage, in particular for females with autism? We explored the social nature of restricted interests in a sample of 96 females and 99 males with autism. We found that females had lower severity scores on the restricted subscales of the RBSR and had more restricted interests that could be considered social in nature, such as in people and in animals. But even beyond the categorization of their interests, females tended to demonstrate their interests in more socially appropriate ways. So for example, if we compared a young boy with an interest in snakes to a young girl with an interest in cats, the young boy watched YouTube videos of snakes, collected snake figurines, and knew all there was to know about snakes. The young girl, on the other hand, also knew all there was to know about cats, but would also write letters to animal activists. She volunteered at a cat rescue, and eventually, problematically so, ended up at one time fostering tens to hundreds of stray cats in this particular example. So these results, in my opinion, point to another sign, another tool we can use in our wait and see model that may point to more nuanced language use phenomena apart from just the sheer number of words that someone has. In addition to some interesting sex differences in how language, if acquired, could be used in social settings. So let's talk about another potential sign of our wait and see model. We can learn a lot by comparing the signs of autism and contrasting them to other seemingly distinct conditions, such as auditory neuropathy spectrum disorder, or ANSD. So very similar to ASD in their acronyms too. ANSD is a particular type of hearing loss that isn't super well understood. Sound seems to enter the ear normally, but somewhere between the ear canal and the organization of the auditory cortex, the sound waves or perception are altered. ANSD and ASD are remarkably similar. Children with ANSD often have other comorbid concerns like premature birth, infection, and neuropathic disorders, but there are also plenty of cases with no risk concerns at all. We don't really know the etiology of ANSD, and right now cannot predict the rate of occurrence. Speech outcomes are incredibly heterogeneous, as indicated by the spectrum label here. And to date, researchers and audiologists don't really have a way to predict which children with ANSD will or will not develop language, much akin to ASD. So if I were just to show you this list here, it would very easily apply to autism as it does to ANSD, although these two disorders have never actually been linked in research. One of my most recent works in collaboration with Ohio State University looked at neurophysiological and behavioral representations of speech perception in children with ANSD. We collected behavioral measures of speech perception and EEG measures while children listened to the ah-ba, ah-pa voice onset continuum. Children were reporting whether they heard ah-ba or ah-pa, and the gap duration where they replied at chance was considered their gap detection threshold. We took behavioral responses from each subject, such as, we'll do subject 3 here. If subject 3's behavioral 50th percent threshold was right about 30 milliseconds, sorry, technical errors here, right about 30 milliseconds. If we compared that behavioral result to their EEG result, we'd also see that their first acoustic change complex detection also started around 36 milliseconds, which is almost in perfect alignment with their behavioral threshold. As a whole, our results also showed a significant relationship between the objective measures and the subjective or behavioral category response. Also globally, the behavioral categorical boundary and objective behavioral categorical boundary were pretty good predictors of their expressive language skills. To date, this is the first published work that has any indication of a potential objective and behavioral method to assess language readiness and response to amplification in children with ANSD. So not only does studying this population provide us with a unique vantage point into the C of the wait and see model, but it provides us with an interesting modality to track, this neural activity that could be an early indicator of language readiness. So could this type of neural indicator be tracked in infancy? Excuse me. It'll be crucial to investigate in infancy as it's a developmental period where well-established behavioral signs of language development have yet to emerge. So understanding the neural underpinnings of language could help us identify several signs that can be used to predict behavior. I can understand that many of you might be thinking that infancy might be a little bit too early to start the wait and see process, and maybe developing measures this early could lead to some false positives. But what if I told you that we have years of research that tells us not only does neural activity linked to language development come online during infancy, but that we have sensitive markers for this behavior? So a key component of my research program also focuses on leveraging the basic science, and particularly work on social information processing in infants to detect infants' preferences for specific kinds of speech. Overall, I'd say we know pretty few things about infants globally, apart from they're quite wonderful. But we do know that their preference for infant-directed speech is fairly robust and replicable. As evidence from the Many Babies Consortium, in which our lab participated in these past 3 years, while there's still some marked variability in the IDS preference, especially by method, as you all can see there by color, the overall effect size is quite positive and robust. And infant-directed speech, or IDS, for those of you not in the infant field, is the way that caregivers speak to babies, with elongated vowel space, shorter speech, repetitive utterances, and hyperarticulation. Infants reliably prefer this type of speech to adult-directed speech, which is how I'm talking to you right now. And how much infants attended this speech is a pretty good indicator of their later language development. So could we use the power of the social context to increase infants' preferences for infant-directed speech? So we primed infants with social or non-social primes to see if we could impact or really improve their preference for IDS. And to cut this story short, we found no effective prime. In fact, we achieved remarkably null results. Infants preferred IDS over ADS regardless of prime, pretty much all the time. We wondered if maybe this was too robust of a preference to prime, but when you looked at the variability, we had a pretty good range here. It wasn't too robust. We could move these variables around. So although our effects were null, we took this variability as a promising sign. There is data here for future research to use basic behavioral principles in infancy as a promising predictor of language development, and perhaps maybe looking at this variability from a neural level is a good future direction. So in conclusion, while a lot of work remains to be done to improve our wait and see approach, I believe the answer resides in the careful integration of these three kind of somewhat merged yet somewhat disparate camps of developmental psychology, clinical psychology, and speech and hearing sciences. For my career moving forward, I'd like to spend more time in the overlap of these kind of Venn diagrams, looking at infants at greater risk for autism, like ASIBs, young infants with hearing loss, and also children with autism and hearing loss. I look forward to numerous collaborations, hopefully with many of you all here, and hopefully 30 years from now, we won't just have to wait and see how language develops before intervening. So thank you all so much for your attention, and let me know if you have any questions.